Alif. I'm going to talk about the technique we use for the sample we selected. So actually we use the systematic sampling method, which form of random sampling. The total student population is 264, and we selected only 40 students as our sample. So we divided the population into smaller parts based on our sample size. For the interval, we divided it 264 by 40, which equals to 6.6. But after we consult with our lecturer, she suggests us to choose number 6. So the interval to selecting a student is 6. Next, to randomly selecting the starting number between 1 until 6, we use spin wheel, and the number chosen by spin wheel was 6. So we started at number 6 and we selected every 6 students after that. Therefore, the selecting students are numbered by 6, 12, 18, 24 and up to 234 and 240. Now I'm gonna pass to the Haikal for his presentation.
Thank you, Ali, for your explanation about the techniques. Next, we move to the qualitative data. From the data given, such as gender, program, and residency, we choose gender as our qualitative data. This is our frequency table. From the frequency table, we can simplify that the male is lower than female. The male is 19 and the female is 21. From the frequency table, we can make a bar graph and pie chart. From the bar graph, we can know the females are more than the male. For the pie chart, we can know the female is 52.5% while the male is 47.5%.
Thank you, Haikal. My name is Taufik. I will explain about quantitative data. This is our group frequency data. From this, we generate three graphs, which is histogram, frequency polygon, and ogive. Let's see.
For the histogram, this is our histogram. So how do you want to do it a histogram? Histogram need a midpoint and also frequency.
Next, I will show our polygon frequency, where there is a number of students and midpoint. This is our graph.
Wait. Before I forget, this is our last graph, which is ogive. Ogive use cumulative frequency and also upper boundaries. Let's see. Next, I will pass back to Ahmad Taufik.
Thank you, Haikal, for giving me opportunity to continue this presentation. I will explain about data analysis. Data analysis have 3 points, which is mean, mode, and median. How I calculate the mean, which is using this formula, and the answer is 286.75. Next, the mode is determined using the model class formula. Based on our data, we calculate the mode, which is use this formula, and the answer is 371.65. For the median, we apply the median class formula, which is this formula, and the answer is 293.36. Next, we examine the spread of the data using quartiles. The first quartile is calculated as, and the answer is 210.50, and the third quartile is found as, and the answer is 367.17. Next, let's analyze the distribution of squareness, which is by comparing a mean, median, and mode. This is our graph of distribution squareness. In this graph, we observe that the mean is lower than the median, which is the mean is 286.75 and the median is 293.36, and both of mean and median is lower than mode, which is the mode is 371.65.
Now I'm going to explain how to calculate standard deviation from a set of data using a frequency table. This is the table we are using it. It includes the frequency f, midpoint x, frequency times midpoint fx, midpoint square x square, and frequency times x square fx square, which are using for our calculation. So the first step, we find the total of frequency, which is 40, and we find the total of fx, which is 11,470, and we find the total value of fx square, which is 3,571,460. So we just put this value into the standard deviation formula, and then we can get the answer 84.02. Now let's move to the Pearson measure of skewness. Skewness is a measure of the asymmetry of a data distribution. In this case, the mean is 286.75. The median is 286. The mode is 371.65, and the standard deviation is 84.02. So to get the skewness, we need to use the skewness formula, which is mean minus mode divided by standard deviation, and we get the result negative 1.01. This indicates the data distribution is negatively skewed, and we can confirm that from the graph visually. That where the peak of the data distribution lies to the right and the tail stretches out to the left. Then let's look at the coefficient of variation. This is a standardized measure of dispersion, which allows us to compare the level of variation between different data sets, regardless of their scales or unit. So for the formula, we use standard deviation divide by mean, multiply 100, and we get 29.30%. This means that the data has a variation of 29.030% relative to the mean.
This is comparison of our group and other group. This is our group graph, and this is the other group graph. That's all.